So now we're going to finish up Chapter 2 with Section 2.3, Graphs that enlighten and ones that deceive. So the first thing we'll quickly mention is dot plots, and that's another way to graph data. We will not do a lot with dot plots, just understand the basic idea behind them. So we're given 13 people and how much cash they have in their wallet. So $25, $30, $35, $35, $35. So to do a dot plot, you're literally just making dots and you're making them above the value along the horizontal line that we have here. So it's a horizontal line with some dots. So notice that each of the lines that we have, so notice we have 1, 2, 3, 4. So each one of those is going to be, if you may or may not have noticed, is going to be a $5 difference. So when we look at where to put them, like the first value is 25, so I'm going to go $5 from that, which is right here. So I have a dot here, and then I have 30. So since the difference is $5, I have 20, 25, 30. I then have 35, and I have 3 of those. So important things, I just want to make them an equal size apart. I want to make the dot an equal size, all the dots the same, and then I want equal distance between them. So if you want, you can pause and put the other ones on. And then we have one huge number, 150, so that's going to be way over here. So when we look and are asked essentially what is the shape of the distribution, we should go back to the end of section 2.2 and understand that the shape of this is approximately normal. And that's because you have a lower frequency and then you rise in the middle and then you come back down. Now when it asks about an outlier is a data value that doesn't really fit in with the other data values. So it literally lies outside all of the most common values that you have. So we have one of those. It is the person who had $150 in their wallet. And so we consider that value an outlier. Everything else, the 60 would not be an outlier. It's still close enough to the rest of the data values, but that 150 is like way out there. So notice that without that outlier, your data really looks normal. And sometimes we will get rid of outliers in order to do certain things with data. Okay. And the other graph, and this is the last one, the last type of way to display data, is a stem plot. And a stem plot is the idea of having data that is a stem and then a leaf. And we're actually going to be putting this on the next page because I didn't have this space. But we're going to make a stem plot with this data. So it's the wages of 30 randomly selected college students. So that's like $11.50 for an hour. $13.40 for an hour, and so on. So when we create this stem plot, what we're going to be doing is we're already given the tens unit. So that's your dollars in this case. That's the dollars part. And then our leaf is basically the cents, and that's our cents are all in multiples of 10. So we don't have like 53 cents or something. So we take a look at our data, and for example, the first data value is 11.5. So what we're going to do is the 5 is going to go here. So this is literally kind of like a decimal point right here. And so the 5 is going to go here. However, what we have to do is we have to make sure that our data values go from smallest to largest. So if you look at all the values for 11, we have 11.5, we have 11.8, we have 11.6, we have 11.0, we have 11.2, 2. Okay, so that's all of them. So the way that that would actually go in the stem plot would be 0, 2, 5, 6, 8. And I would try to put them approximately the same distance apart, and I would put them from smallest to largest. So if you want, you can pause it and see if you can fill in the rest of the stem plot. If you want, I can do one more. Let's look at the 10. So anybody that was only making $10 an hour, we have a 10.8, we have a 10.9, and we have two 10.9s. So we have this. And actually, they're already in order the way I have them. So I'm going to have an 8 here, and then a 9 and a 9. So notice again, equal distance apart, trying to kind of, because we're going to try to visually look at this. So go ahead and pause and see if you can fill in the rest of the leaves from the rest of the stems. The reason I am doing it fast is because I've already done it, of course, on my notes, but this would be everything. And so that's a stem plot, and so that can take different amounts of time depending on, you know, where you're at, but as long as you understand it, that's important. We are asked, what is the shape of the distribution? So with the stem plot, the reason that I try to put things in the equal distance is because if you put this up on its side, you'll notice that if we just kind of do this little line here, you know, we have something that looks like this. And of course, I could have been a bit more extreme there as I was coming down. So the reason we're saying skewed right is because we do have that higher frequency in the left and the lower frequency on the right, and then that extends out. So the skewness is always wherever the tail is. So in this case, skewed right. And then the last couple of things here, we do very little with these, so it's not something to spend a lot of time on. The Pareto chart, it's a bar graph. We really don't do a lot with bar graphs. The bars are supposed to be in descending order of frequency, so this is actually not a good indicator of a Pareto chart, but it's just a bar graph, largest to smallest frequencies. Many people have already seen pie graphs and charts, so that's what you're seeing here. And again, we really don't do that much with them because they, to be honest, are not the best representation of data, statistically speaking. And deceptive graphs. So you want to be reminded that every time you see a graph, it really could be trying to influence you into feeling a certain way about it. And one of the ways that it may do that is using a non-zero vertical axis. So that's the idea that, notice that this does not start at 0. This does not start at 0. So what that does is it exaggerates differences. So you'll notice that if this started at 0, the graph on the left-hand side, the percentages 5.2052 and 5.1852, very, very close together, like incredibly close together. Those numbers are almost the same. But because of the way that they've skewed the vertical axis, those differences look enormous. And the same thing over with the housing prices. When you're starting at 50,000 instead of 0, you're thinking, you know, that the housing prices maybe are not as different as they are. And so, you know, not starting the value at 0 is a really good way to be deceptive with a graph. And then the last thing, we really will not see pictographs in this class. Typically they can be really quite misleading because they take these pictures which are meant to convey something. Notice that the pictures are 3D. So you got this candy corn and it looks like a real piece of candy corn, or a trash can looks like a 3D trash can. But it's denoting data that's two-dimensional. And it's doing that for different amounts. So for the Halloween candy, you can see that Shayna collected, it looks like, you can see that's like 4, so maybe 18 pieces of candy. And Michael over here with his 36. So Michael got double what Shayna got. But when you look at the picture, it just looks so much more, because really, like, when you add volume to things, it's not just a a linear difference. So it'd be a lot better to use a bar there for a bar graph to just show like, oh, this is 18 and this is 36, and you can see that difference. So typically these are pretty deceptive type graphs. Again, you won't be drawing anything like this, so just understand that they can be deceptive to make us think that amounts are a lot larger than they are, or smaller than they are, depending on which picture you're looking at. And that's section 2.3.